Hey everybody, so today we are going to be doing 8-7, which is applications of right triangle trigonometry. Just a quick reminder, this is the last section of chapter 8 in your textbook, and we will be getting more in depth with our trig. Outside of our textbook, I'm going to be putting together a trig packet for you guys. For people in person, I'll have copies available for you in class. Remote students, if you'd like to pick up a hard copy, let me know. I can have one available for you, or you'll be able to print everything off on Canvas. And that'll be Thursday, Friday, and then next week. So today, let's start off with some vocab. We have angles of depression and angles of elevation. So what this is the angle between the horizontal and the line of sight. So how this kind of works is, if you take a look at this diagram here, we have a person, and when they are standing up straight and looking just, straight out, horizontal to the ground, right, we create this line of sight that is horizontal to the ground. Now, let's say there is something below that person that they want to look at, some object. Their line of sight is going to change from a horizontal line, from a horizontal line, and they are going to look downward toward that object. And what that does is it creates an angle of depression from their original horizontal to that new line of sight. And that is an angle of depression because they are looking downward. Again, they're going from looking out horizontally to downward. Okay, so we refer to that as being negative from horizontal, not a negative angle, just you're doing like a negative motion because you're looking down. Angle of elevation is positive from the horizontal because you are looking up. So again, same person, they are looking out horizontally, and then they turn their line of sight upward towards an object above them. This is also going to create an angle, except this is an angle of elevation. Again, they went from their horizontal and looked up and created an angle of elevation. Within any given scenario, an angle of elevation and an angle of depression must be equivalent. So actually, before I get into this diagram, just real quick, I kind of want to show you how this all ties into our right triangles. If you draw any right triangle, let's say you just have a basic right triangle like this, right? You have your horizontal line along the bottom, and then this angle here would technically be an angle of elevation because it is going from horizontal upward. Then, if you kind of flipped that picture upside down, like this, you have a horizontal, and then, so let me actually look at that in a different color. So you have your horizontal, and then you are looking downward. So here you would have an angle of depression. So that's how that ties into your right angles. So we are going to be using your sine, cosine, and tangent ratios as well as your inverse ratios. So you'll use your inverse ratios when you're looking for an angle of depression or elevation, and you'll use your regular sine, cosine, and tangent ratios if I give you an angle of depression or elevation, and maybe you need to find the distance away from something, or the height of an object, or something like that. So again, within a given scenario, the angle of elevation and the angle of depression must be equivalent. This is because if someone goes from their horizontal and adjusts their line of sight downward, and someone else goes from horizontal and adjusts their line of sight upward, these two measurements would have to match up. They actually create alternate interior angles because you have two horizontal line of sights, right? So if someone's up on something high, maybe they have a horizontal line of sight. Someone down below would also have a horizontal line of sight. And when they adjust to either look down or look up, their new lines of sight meet and form a transversal. So up at the top here, your angle of elevation looking downward would then meet your angle of elevation looking upward. And these would have to be the same angle because they're actually alternate interior angles. So if you take a look at this diagram here, this is kind of illustrating what this could look like in a real life scenario. You have a lighthouse and maybe there's someone inside or on the top of the lighthouse, and they are looking down at this sailboat on the left here at an angle of depression of 2 degrees. Right? So they look out horizontal and then adjust their line of sight to look down at this sailboat that at an angle of 2 degrees. Well, the same thing would have to happen from the sailboat to look at this lighthouse. They would have to then look up at a matching angle of elevation of 2 degrees. You can use this information to do things like solve for the distance from the sailboat to the lighthouse. Okay, just depending on the information. Or you could maybe use, if you're given other information, maybe you could use it to find the height of the lighthouse. Different things like that. So if we look at what this says down here, it says in the scenario above, if the top of the lighthouse is 25 meters above sea level, so this is 25 meters above sea level, the distance x between the boat and the base of the lighthouse can be found in the following way. So x is actually your horizontal distance, so think the base of the lighthouse towards the sailboat, that is horizontal distance, and we have our height of our lighthouse. So what this actually does, and what you're going to do anytime you solve for a angle of elevation or depression problem, is you're going to, or what I recommend you do, is give yourself a little sketch. Draw yourself a right triangle. Doesn't have to be perfectly to proportion. It's just to help you out. So we know that our lighthouse has to be this perpendicular measurement here because your lighthouse is standing up, right? It's coming out of the ground. So our lighthouse is 25 meters above sea level, right? And our sailboat would be down here. Okay, that's how this kind of works. And it says, so we have an angle of elevation from the sailboat to the lighthouse of 2 degrees. And remember, that would also match your angle of depression from your lighthouse to your sailboat. So you could look at this really in either direction. And we want to find our horizontal measurement here, our distance from the base of the lighthouse to the sailboat. Well, this is a trig problem. I know my angle is 2 degrees. I have that my opposite measurement here is 25, and my adjacent is x. So this is a good place to remember your SOHCAHTOA, S-O-H-C-A-H-T-O-A. O and A means we need to use tangent. So remember, when you set this up, do tangent of your angle, 2 degrees, equals your opposite, 25 over your adjacent x. X is on the bottom, so this needs to turn into division. X equals 25 divided by tangent 2. So divide that, 25 divided by tangent 2 equals about 715.9 meters. Okay, so again, draw yourself a right triangle, figure out, okay, do I have my height? Do I have my horizontal distance? What do I know here? And try to label it appropriately, and then figure out what trig you must use. Just a quick thing for identifying those angles. Two people at points X and Y sight an airplane at A. What is the angle of elevation from X to A? So from X to A, again, you have your horizontal, and then you are looking upward because it's an angle of elevation. So that would have to be that 35-degree angle. Then in the next one, it says, what is the angle of depression from A to X. So these are looking at the same points, but the other way around. So these angles should match. They should both be 35. So let's take a look from A. You have your horizontal, and then you look down towards X. And if you take a look here, that's made up of a 12 and a 23-degree angle, which would give us our 35. Then what is the angle of depression from A to Y? So again, you're starting off at A, you are looking at your horizontal, and then down towards Y. That is a 23-degree angle, and the angle of elevation from Y to A should match. So from Y to A, you have your horizontal, and then look up towards A, right? And you have your parallel lines here, so you would have your alternate interior angles, and that would also need to be 23. A driveway, is it a 15% grade? This should help with a problem that was on your previous homework. It had a problem like this, and I got some questions on it, and I just wanted to make sure that this got cleared up. I also sent this out in an announcement. A 15% grade is like an incline, but it's not a degree incline. It's in a different kind of unit. So we can turn this into a trig problem by giving ourselves a triangle. So again, I'm always going to draw my triangle here. So I'm going to draw a little triangle over here for this problem. And what a 15% grade is it means that your driveway is being elevated 15 degrees. So you can think of this 15 degrees as almost like a ratio. It means for every 100 feet, you go horizontally, or well, not feet, units, we'll say units. For every 100 units you travel horizontally, you travel 15 units vertically. Because if you take 15 degrees, that would be 0.15, right? Which is 15 over 100. So for every 100 units you travel horizontally, you travel 15 units vertically. So that's how a 15% grade works. If it was a 30% grade, it would be 30 and 100. A 7% grade, 7 and 100, right? And we want to find our angle of elevation. So our opposite is 15, our adjacent is 100. So since we're going to find an angle here, we need to use our inverse trig ratios. So 15 is our opposite and 100 is our adjacent. O and A means we need to use inverse tangent. So inverse tangent of 15 over 100 equals, and just plug that into your calculator. So inverse tangent 15 divided by 100 is going to be approximately 8.5 degrees. Okay. If a driveway is 12 meters long, about how much does it rise? So this time, it's saying to use your angle of elevation that we found in A and find out how much our driveway rises. So rise would be a vertical measurement if our driveway is 12 meters long. So this is a great example of figuring out where all these labels go. So I'm going to draw myself another right triangle here. And if my angle of elevation is 8.5, that's going to go right here. And my driveway is 12 meters long. So you got to think about where you would put this. Well, a driveway is not a vertical measurement, so you're not going to put it on the vertical part of your triangle. And it's already told you that your driveway is at an incline of some sort because you have an angle of elevation, so it wouldn't make sense for it to be your horizontal measurement either. Since it's at some kind of an incline, your 12 is going to have to be your hypotenuse. Okay, your driveway is not perfectly horizontal in this situation. And we want to find out the rise. The rise would be a vertical measurement. I'm going to label that as Y. So I have my angle. Y is my opposite. 12 is my hypotenuse. So O and A means I need to use sine. or I'm sorry, O and H means I need to use sine. And this is just going to be a regular sine ratio. So sine of 8.5 equals my opposite, y over my hypotenuse 12. I'm going to take 12 times sine of 8.5, and you should get approximately 1.8. I think it's like 1.77 something, so we're going to round that to 1.8, and this is meters. Try to use the appropriate units when you can. Number 3, a ski run is 1,000 yards long with a vertical drop of 208 yards. Find the angle of depression from the top of the ski run to the bottom. So again, this is going to be trying to figure out where all your measurements go. I'm going to draw myself a just generic right triangle to start. It is saying my ski run was 1,000 yards long. So think about if you're skiing. You are not skiing perfectly horizontally or perfectly vertically, right? This is saying a ski run. That's like you're going down a hill. So your 1,000 yards is going to have to be your hypotenuse here. And it says you have a vertical drop of 208 yards. So that is your vertical measurement here. Find the angle of depression from the top of the ski run to the bottom. So your angle of depression, remember you have to go from horizontal and then you look down. So this little angle here is your angle of depression. Depending on how you drew your triangle though, something to keep in mind, again, there's multiple ways you can draw this. I'm just giving you one example. But your angle of depression here is going to have to match your angle of elevation. It doesn't specify, you know, I mean, I guess it says from the top of the ski run to the bottom, but the angle from, if you're going from the top to the bottom, is going to have to be the same as from the bottom to the top. So you can look at this in a variety of ways. I'm just giving you one example of how you could draw your diagram. So if you were to draw it in this way, we are looking for our missing angle here. So I know I need to use inverse ratios. I have that my opposite is 208 and my hypotenuse is 1,000. So O and H means I need to use inverse sine. So inverse sine of my opposite, 208, over my hypotenuse, 1,000, equals inverse sine 208 divided by 1,000. You are going to get approximately 12 degrees. If you are drawing different diagrams and you're not sure if what you're doing works, just let me know. Again, there's a variety of different ways depending on how you want to draw your right triangle. All right, and the last problem for today, number 4, it says the highest point along a cliff is 80 meters above the shoreline, or the lake shore. A surveyor stands on the top of the cliff looking through a 1.5 meter tall transit instrument. He spots a boat out on the lake at an angle of depression of 38 degrees. How far to the nearest tenth of a meter is it from the boat to the base of the cliff? So again, I'm gonna draw a generic right triangle diagram here. Again, how you draw this is kind of up to you. But if this guy is measuring from the top of a cliff, I'm going to go with it. He is probably standing up here somewhere. Now it says that this cliff is 80 meters above the lake shore, so that is going to be a vertical measurement. Now it does not say that he is measuring from the ground. He's measuring from this 1.5 meter tall transit instrument. So there is this instrument up here that he is measuring from that is 1.5 meters. It's not really supposed to look like an eye. It was just a little thing to show I was kind of extending my segment. Right, so that's 1.5 meters. So what I'm actually going to I'm going to do then is adjust my triangle a little bit. And again, how you draw this is completely up to you. I'm going to just adjust my triangle so that this entire measurement is 81.5. So whatever we are looking down from is 81.5 meters above the lakeshore. It says then that he spots a boat out on the lake at an angle of depression of 38 degrees. So that means there's this boat out here, right? And he is looking at it at an angle of depression of 38 degrees. So remember, when you're dealing with an angle of depression, you're going from horizontal, and then you are looking down. So that means that this angle here is 38 degrees. Well, something to keep in mind is that if that angle is 38 degrees, then the angle of elevation from the sailboat up to the top of the cliff will match it. And that just kind of gives you some different ways to set up your diagram depending on how you want to do this. So it says, how far to the nearest tenth of the meter is it from the boat to the base of the cliff? So that is a horizontal measurement. So I now can figure out my opposite, my adjacent, and my hypotenuse. So from my 38-degree angle, my opposite is 81.5. My adjacent is x. So O and A means I'm going to use the tangent ratio. So tangent of 38 equals opposite 81.5 over adjacent, which is x. This is going to need to turn into division. So 81.5 over tangent of 38. Plug this in. 81.5 divided by tangent 38, and you are going to get about 104.3 meters. All right, let me know if you guys have any questions, and this assignment will be due on Monday or Tuesday, depending on if you are 4th or 6th block. Again, let me know if you have any questions.